Welcome to my algebra class. We're on chapter 11, section 4. We're going to be working with irrational numbers. An irrational number is a non-terminating, non-repeating decimal which can't be written as a fraction. For example, the square root of 3. If I used a calculator for the square root of 3, I get a non-terminating, non-repeating decimal. If you're asked to simplify a radical, they want you to remove the perfect squares under the radical. So you have to remember try to find your largest perfect square each time you do this, otherwise you have extra steps. So if you remember your perfect squares, 25 would be the largest perfect square in 75. So that would equal the square root of 25 is 5. I can take that out, and the 3 is left. The square root of 32, 4 times 8 makes 32, but the 8 has another 4 in it, so the largest perfect square is 16. So I take out the square root of 16, which is 4, and radical 2 remains under the radical sign. The square root of 162, use your calculator, but try your perfect squares. 1, 4, 9, 16 doesn't work. Up to 81. Let's see, what goes into 162? So 162 divided by 2 equals 81. So we have 81 in there. So we break it up into the square root of 81 times 2, and the square root of 81 is 9, so we have 9 radical 2. So that's simplifying a radical. If they ask you to approximate a square root, you use your calculator. You don't need to use that table on 682. So the square root of 75 approximated, let's say, to the nearest tenth. I put 75, hit the square root key, and that would be 8.60. Let's put that over here. That would be 8.6 to the nearest tenth. Excuse me, that'd be 8.7. If you had to approximate the square root of 32 to the nearest hundredth, that would be 5.66. The 6 here would make that 5 a 6. And if we approximated the square root of 162 to the nearest thousandths, that would be 12.728. The 9 would make the 7 and 8. So that's what we're going to be working with on your assignment. Keep your calculators handy. We're on page 522, and it's 1 through 50. So problem number 2. The directions are to simplify. We have the square root of 28. And the largest perfect square in 28 would be 4 times 7. The square root of 4 is 2. And we have radical 7 left. Problem number 4. You have the square root of 50. Perfect squares, 25 would be the biggest one I can think of, times 2. So the square root of 25 is 5. That comes out, and radical 2 is left. Number 6, the square root of 24. The largest perfect square in 24 is 4. So you can take out the square root of 4, which is 2, and you still have radical 6 under the radical. Number 8, the square root of 120. Let's see, that's 4 times 30. and I don't know of a perfect square in 30, so the square root of 4 is 2. That goes out, and we have 30 underneath. So it's 2 radical 30. Problem number 10, we have 6 radical 108. Let's see, 9, let's try 9. So it'd be 6 times 9, 9 goes in there 12 times. But 12 has a perfect square in it, which is 4. So we actually have 6 radical 36 times 3. So the largest perfect square in there is 36. So the square root of 36 is 6. So we have 6 outside already times 6 because we're taking out the square root of 36. And there's 3 left. So that's going to be 36 radical 3. Problem number 12, we have 9 times the square root of 90. I can see 9 in there, 9 times 10, and there are no perfect squares in 10. So the square root of 9 is 3. That comes out. And you have 10 left. So it's 27 radical 10. Problem 14, we have the square root of 324. Let's just check and see if that is a perfect square. It is. It's 18. So when you get to 3-digit numbers, you might want to check on your calculator to see if they're perfect squares. Number 16, you have 14 radical 75, and we've done this before, so we know 25 is the largest perfect square there. The square root of 25 is 5, so it's 14 times 5, radical 3. 14 times 5 is 70. So we have 70 radical 3. Number 18, the square root of 864. I'm going to simplify it. So first let's check and see if it's a perfect square. I don't think I entered it right. 864. Nope, it's not a perfect square, so we're going to have to try something else. Let's see what happens. We know, let's see. 4. Well, we know 2 goes in there. Let's try a bigger one. 9. See if 16 goes into 864. It does. So we have 16 times 54. Is there any perfect squares in 16? Excuse me, in 54. That's 9 times 6. So we have the 9 and the 6. So what's 16 times 9? That's 144. Times 6. So that would come out 12 radical 6. Another way you could have done this here is take out the square root of 16, which is 4. The square root of 9, which is 3. And you have radical 6 left. So that would give you 12 radical 6. So either way works. Problem number 20. You have 3 radical 160. I can see 16 times 10 works. And 16 is a perfect square. Take out the square root of 16, which is 4, so I have 3 times 4 radical 10. Multiply, I get 12 radical 10. The square root of 432. We can check it out and see if it works. It doesn't. So let's see if we can find a perfect square. We know 4 goes in there. You can see that. So this is the square root of 4 times 108. And I know 108 is 9 times 12. And within the 12 is a 4 and a 3. So I could multiply those out and figure out what the perfect square is. What is that? 4 times 9 times 4, whoops, is 144 again. So we're going to get 12 radical 3. And the other way would have been to just take out the square roots of the perfect squares. So the square root of 4 is 2, the square root of 9 is 3, and the square root of 4 is 2. And 2 times 3 is 6 times 2 is 12 radical 3. So whichever way you do it, it's going to work. (24). We have 4 radical 363. Let's see what we'll go. Well, let's see what happens if I break that up a little bit. 3 times 1, 2, 1. Oh, there's our perfect square, 121. Sometimes you just got to keep trying different numbers and seeing what you can come up with. It's a little bit of work. So I can take out the square root of 121, which is 11. Radical 3, so I get 44 radical 3. And number 26 is 5 radical 567. Well, I could see 7's going to go in there. Let's see what happens if I divide that by 7. That's going to be 7 times 81. So 81 is a perfect square. I can take that out. 5 times 9, radical 7. So I get 45 radical 7. (28), I have the square root of 9,200. So I know that's 100 times 92. And square root of 100 is a perfect square. 92 is 2 times, let's see, is 4 go in there? Yeah, 4. We want a perfect square, so we want to use 4. So 4 times 23. So those are my perfect squares. Square root of 100 is 10. The square root of 4 is 2. So those are gone, and I have 23 left. So it's 20 radical 23. And the last one of this type of problem, 5 times the square root of 2,050. Well, let's see. If I take, well, it's got 5s in it and 10s, so let's try perfect square 25. So 2,050 divided by 25. It works. So it's 25 times 82. So the square root of 25 is 5, so we get 5 times 5 radical 82, which is 25 radical 82. Okay, the last part, you're going to be using your calculator. They want you to approximate the first set to the nearest tenth, the next set to the nearest hundredth, and the last set to the nearest whole number. So number 32, you need your calculator. The square root of 500 to the nearest tenth would be 22.4. Be sure you do these and don't just copy the answers. 34 is negative square root of 600. So 600 square root. It's negative 24.5 to the nearest tenth. Number 36, negative square root of 4,800. So 4,800 square root. It's going to be 69.3, and it's going to be negative. .38 is positive negative square root of 5,600, which is going to be 74.8. So positive negative 74.8. The next set, we're rounding to the nearest hundredths. So 42 to the nearest hundredths would be 6.48. Number 42 is negative square root of 0.3. To the nearest hundreds would be 0.55. So negative 0.55. 44, positive negative square root of 0.73. That's going to the nearest hundred, it's going to be 0.85. Positive negative 0.85. And number 46, negative square root of 0.08. Oops. To the nearest hundredths is going to be negative 0.28. And the last set of problems approximate each square root to the nearest whole number. So number 48, 240,000. To the nearest whole number is either 489 or 490. The 8's going to make it 490. And the last 150, 580,000, the square root of it. To the nearest whole number, it'd be, the 5's going to break the 1 or 2, so it'd be 762. That concludes the evens. Be sure you check the odds at the back of the book as you do the